In this video, we are continuing section 1.4 on factoring, and we are going to focus on factoring expressions with three terms. So stuff with three terms is typically the stuff that you would practice the most in algebra. So some of this stuff may be a little bit more of a quick review for you, and if that's the case, that's great. But nonetheless, I am going to do a brief review, even of some of the more basic things with factoring three terms, because I think it's worth it to see some of the stuff again, because it may have been a while, maybe back to Algebra 1 here. Okay, so how do we factor stuff with three terms? First, you factor out the common terms, if there are any. Once you do that, you're typically going to be left with a quadratic. So something of the form ax squared plus bx plus c. And typically you would have seen quadratics, a bunch in algebra. So you may have, methods that you've seen before about how to factor them. One bit of terminology is we usually call this number a in front of the x squared the leading coefficient. So I'm going to break up our strategies into cases based on what a is. So first, if that leading coefficient is 1, how can we go about that? Let's get into an example. So I got this expression here. First, are there any common terms? And yes, all the terms have t in common. So I can factor it out. That'll leave me with t squared minus 10t and then plus 24. Awesome. And so at this point in the parentheses, I have this quadratic left over. And you may have a method that you remember from algebra class about how to factor quadratics. So I want to show you one such method. It involves drawing an x. And then what I'm going to do is this middle coefficient, negative 10, I'm going to put at the top of the x. This ending coefficient, the 24, I'll put it at the bottom. And then what I need to do is I need to look for two numbers that add to negative 10 and they multiply to 24. So, I won't count it down, but what I'll say is give this thing a quick, 15-second pause and see, can you find those two numbers that add to negative 10 and multiply to 24? Give it a quick pause. All right, so hopefully you had a chance to think about those. It turns out that what works is negative 6 and negative 4. And those are the numbers that are going to go in this factorization. So that t is going to stay out in front. And now my quadratic, it's going to factor is, I'll have a t and then a t. And then those numbers that I just got, the minus 6 and the minus 4. And I could check this if I wanted to. If I FOILed out this stuff, it should give me my t squared minus 10t plus 24. Okay, and that's as far as I can take it. The thing in each of these parentheses right now, you can't factor them further. Nothing's common. They're not perfect squares or perfect cubes, so I can't use one of those formulas. Okay, all right, let's get right into an example of, what can I do if that leading coefficient, a, is not 1? This is typically a bit more complicated. So I want to factor 8x squared minus 6x minus 9, and I want to talk about two ways I can do it. First, I'm going to do it by trial and error. Okay, so trial and error is, kind of essentially something similar to what I did with this x, but kind of using some educated guess and check, to figure out what might work. So when I try to do this by trial and error, I know it's going to factor with two parentheses like this. And whatever these first two terms are, they have to multiply when I FOIL it to give me this first term, 8x squared. And then, whatever these last two terms are, they'll have to multiply to give me that last term, that negative 9. And then when I do that, when I do these outer terms and multiply them and these inner terms, and then combine those like terms, that should end up giving me this minus 6x. So it's not always immediately obvious what to try to make that happen, and this is why it's called trial and error. We got to do a little bit of educated guess and check to get those values. So, I want to give you some time to try this. I want to have you pause the video for about, 1.5 minutes, maybe 1 or 2 minutes to try this. Pause it in 4, 3, 2, 1. Pause it and try this. Try and see if you can come up with a factorization that works. All right, so hopefully you did that. Hopefully you paused it and tried it. Okay, so I'm going to go ahead and go over what ends up working here. What's the factorization that works? Okay, so it turns out those first terms are going to be 4x and 2x, and the numbers at the end are going to be a positive 3 here and a negative 3 there. And that ends up working here. You could check it. If you now FOIL this out and multiplied it out, it would give you this original thing. Now, this may not have been the first thing that you tried. And if it's not, you would FOIL it out, see if it gives you what you have up here. And if not, you try something different. Okay. All right, so that is the trial and error method. If I do FOIL this out, let's just do a quick check. My first terms multiply to 8x squared. The outer terms give me minus 12x. The inner ones give me plus 6x. And the last ones give me minus 9. And now I can see, okay, combining these middle terms, well, that does give me that minus 6x. So it's going to give me that original. Okay, awesome. So there's another way to do this that's a bit more systematic than this. And this is called splitting the middle. So I'm going to go over how this method works. So it's going to involve doing something very similar to that x that we saw from up above. So now I'm going to try to find two numbers whose sum is b. So b is this middle coefficient. But I'm going to want their product to be, this time, not just the last term, it's going to be the product of a and c. So this first coefficient and that last coefficient multiplied together. So in my x, the sum needs to be that middle coefficient, the b, which is negative 6 for us. And the product needs to be a times c, so that's 8 times negative 9. And those happen to multiply to negative 72. So I'm looking for two numbers that are going to go in these missing spots that add up to negative 6, and they multiply to negative 72. So I want to give you about a minute to pause it and see if you can find those numbers. Give it a quick pause. You might need less time, but about 1 minute to try this. 4, 3, 2, 1. Pause it. Pause it for a minute. See if you can come up with those numbers. Okay. Hopefully you did that. Hopefully you paused it to try it. So now let me go over them. So the numbers that work are, turns out, negative 12 and then positive 6. They add up to negative 6 and they multiply to negative 72. So what do I do with those numbers? Unfortunately, they're not just going to go into factorization like this. And the reason why not is if I did that, my variable here is x, my bad. I get x minus 12 and then x plus 6. If I did that, well, when I FOIL it, the first terms multiply to x squared, but I won't get an 8. So that doesn't quite work. Okay, that's part of the reason why this ends up being tougher when that leading coefficient isn't a 1 like it was up above. So how do I do this? How does the splitting the middle method continue? So next what I'm going to do is I'm going to rewrite the middle term. So I have my 8x squared. I got the minus 9 at the end. But this middle term, the minus 6x, I can rewrite it using these two terms as negative, negative 12x and then plus 6x. Because these two things add up to negative 6. If I put an x at the end of them, they'll add up to negative 6x. Okay, so I'm rewriting the middle term using the things I just got in my x. So now what I have overall is 4 terms. We talked about how to factor 4 terms in the last video. To do that, this is step 3, I factor by grouping. So I'm going to factor by grouping. Okay, so let's carry on down this 4-term expression. So what is this going to give me? I'll end up getting, it turns out when you split the middle, it should always work to group the first 2 terms together and the last 2 terms together. In the first group, what's common? I could take out 4 and an x, and that'll leave me with 2x minus 3. And the last group, I could take out maybe a plus 3, and that'll leave me with 2x minus 3. Now I like this because the first group and the second group have this 2x minus 3 in common. So I get to factor out that common factor. The 2x minus 3 is a common factor. I get to pull that out to the front, and then I write all the leftovers in a big old parentheses. So in the first group, I'm left over with 4x. In the second group, I'm left over with the plus 3. Okay, and I factored this thing. If I compare it to the answer that I had up above, I'm getting the same thing. Awesome. So that's splitting the middle. Okay. So one of the key takeaways I want you to have from this is the trial and error method takes practice to get good at, but once you do have a handle on it, it's quicker. Like me personally, when I have factoring problems like this, at least 90-95% of the time, I'm doing them by trial and error to factor these quadratics. Splitting the middle can be longer, but it is a bit more systematic. It involves less guess and check than trial and error does. Okay, so it's a good, I definitely want you to know how to do it both ways, and we'll definitely get a lot of practice with them. Okay, so let's shift our focus and talk about a couple of special cases now for factoring these three-term expressions. Okay, so the next case is, well, what if I have a quadratic in two variables? What if there's two variables that kind of make this kind of a dual quadratic? So let's look at an example. So what I want to do first in a situation like this is, well, pretend one of those variables isn't there. So I'm going to pretend that all those b's aren't there, but I could also do it pretending the a's weren't there, and then factor that. So I get this easier quadratic now, and well, let's factor this. Well, so I know I'm going to have an A and an A. Then I need two numbers that add to negative 16 and multiply to 64. So that's going to be minus 8 and minus 8. Awesome. Oh, or I could write this as A minus 8 quantity squared. Okay, so once I have that, then what I do is I think about how do I put the variable that I got rid of back into this factorization so that if I were to FOIL it out, I would get back my original expression. So where would I need to put that b that I removed back into this factorization so that it ends up FOILing out to the right thing? Okay, so it turns out that I would want to put it next to that 8. Next to that 8. And you could check it. You could check. You FOIL this out, and if you do, it's going to end up working out to this. One of the ways I know it's going to be next to the 8 is, well, I kind of got rid of the b, especially from these terms at the end. So it's more likely to go with the term at the end. Also, if I had put the b with this a, well, if I were to square it, it wouldn't give me just a squared then. So kind of process of elimination, I could also figure it out. Okay, so that's how I'm going to handle quadratics involving two variables like this. Okay, where I had the a squared and I had a b squared, and then the middle term is something with like an ab. Okay, all right, let's talk about one other special case. Okay, so this is called substitution and hidden factoring. So I want to motivate this with an example. Suppose I have this expression here and I want to factor it. So one of the things I want to notice about this is, so it's a more complicated looking expression. I got this thing in parentheses, it's being squared. Well, does that mean I got to FOIL it out, or what do I do? And then I got some stuff after that. But one of the things that's very nice about this problem is I see this quantity 4a squared plus 3 that shows up in more than one spot. It doesn't show up in all the terms, like it's not part of this negative 36 at the end. If it was, I could factor it out of everything, but it's not part of everything, so I can't just factor it out of everything. So what am I going to do? I'm going to try substituting and picking a new variable. So I could pick any variable I like. Maybe I'll pick y, and I'll let that be that 4a squared plus 3. So anywhere I see 4a squared plus 3, I'm going to replace it and substitute y. So that's going to give me y squared minus 9y minus 36. So this problem is actually an example of what's called a hidden quadratic. After I make a substitution, it turned it into just a simple quadratic. So hidden quadratics will kind of have this more general form where I'll see like some stuff and some stuff squared floating around in there. That's just kind of really strongly indicating that substitution might be helpful. Okay, well now this is nice because this quadratic is a lot easier to factor. So let's factor this. So I'll have y and y, two numbers that add to -9 and multiply to -36. Okay, so it seems like -12 and +3 will work. Okay, so I got this thing factored, but, well, the original problem didn't have y in it. So I need to now substitute back for what y was. So y was 4a squared plus 3. Anywhere there's that y, I'm going to plug back in. 4a squared plus 3, 4a squared plus 3. In the first parentheses, I still got -12. And the second one, I still got that +3 there at the end. Okay, so this now gives me, let's simplify, 4a squared minus 9 in parentheses, and the second one is 4a squared plus 6. I should still ask myself, can either of these be factored further? And it turns out yes. What can I do with this first parentheses? And what can I do with the second parentheses? Give this thing a quick pause for 1 minute. See if you can identify what can I do further to factor each of those. Pause it in 4, 3, 2, 1, pause it, and see if you can figure out how we can factor those further. All right, so hopefully you did that. Let's bring it back and talk about these. So the first parentheses is a difference of squares. I got something squared minus something squared. So what squared is 9? Well, it's 3. And then in the first parentheses, I would need to have 2a, so that when I square it, I get 4a to the 2. Okay, so nice. So if I were to use that difference of squares, I would get the first thing minus the second thing, parentheses, the first thing plus the second thing. That's my difference of squares. In the second parentheses, well, there's a common term. I can take out a 2. And in fact, that 2 that's common, let me give myself some more room. I'm going to move that all the way to the front. And that'll leave me with 2a squared plus 3. Okay, and now that's as far as I can take that. Okay, so I'm going to box this. Okay, so this was a kind of a complicated looking problem, but notice that the key thing was I saw this expression that showed up in more than one spot, and substitution made it become a lot simpler. All right, let's take a look at one more example in this video. Okay, so I got 16x squared t to the 7 minus 6x squared t to the 4 minus x squared t. I'm going to try to factor this. So first, I ask myself, are there any common terms? So all the terms have an x squared in common, and they all have a t. That's the smallest power of t. So now I factor that out, and then I write the leftovers. 16 t to the 6 minus 6t cubed, and then minus 1. So those are my leftovers. Okay, so now I want to think about this thing in parentheses and ask myself, can I factor that further? This one might be a little bit less obvious, how I can make a substitution work here. But one of the things I want to think about is, can I write one of these terms, either t to the 6 or t cubed, as the other one squared? And it turns out I can. If I were to do t cubed and square that, well, that ends up being t to the 6. Okay, so t to the 6 is actually the same thing as t to the 3rd, that quantity squared. Okay, and if I do that, well, then I do see this expression t cubed showing up in more than one spot. So let's sub for it. Let's substitute. I'll pick a new variable, like y. I don't have to pick y. I could, as long as it's something that's not in the problem, so I don't want to pick x or t, I could pick a, or I could pick z. So I'll pick y in this case, though. I'll let y be this t cubed. And if I do sub in, well, the stuff in the front stays the same. I got x squared times t. That's already factored out, and I don't need to do anything more with that. But then the leftovers become 16. That becomes y squared. This becomes y squared, and then minus 6y minus 1. And now I have this much simpler looking quadratic to factor. This was a hidden quadratic. Okay, so, this leading coefficient is not 1, so I could try to do by trial and error, or I could do my splitting the middle. Let's try this one by splitting the middle, just to get some more practice with it. So 16y squared minus 6y minus 1. When I split the middle, I'll make my x thing. So I need two numbers that sum to that middle term, -6, and whose product is a times c. So that's 16 times -1, which is -16. I need two numbers who add up to -6 and that multiply to -16. So it turns out what works is -8 and +2. Okay, so I'm going to use those to split that middle term. So I will still have my 16y squared at the front and then a -1 at the end. But the middle term, I will split it and rewrite it as the -8y and then the +2y. So I'm using these terms that I just got. And as we saw before in this video, now what I do is group, because I have 4 terms. And when I split the middle, as long as I did it correctly, grouping the first 2 terms and the last 2 terms should always work. That's not typically the case in a random grouping problem, but with splitting the middle, that should always work. Okay, so in the first group, I can take out 8y, and that'll leave me with 2y minus 1. And the second group, well, I can't really take out anything. I'm just left with 2y minus 1. Okay, so sometimes that'll happen. So now I ask myself, well, in these two groups, is there like a common factor? And yeah, in the first group, it's this 2y minus 1, and the second group also has this 2y minus 1. Okay, so let's factor out that common factor. So I'm going to write it first. Common factor, I'll pull it all the way out to the front. Pull out that common factor all the way out to the front. And then I start a parentheses where I write all the leftovers. So from the first group, what's left over is 8y. But what's left over from the second group? It might be tempting to say 0. But if I take out 2y minus 1, well, this 2y minus 1 is technically getting multiplied by a 1 here. So when I factor it out, I'm actually left with a draw mode, +1. Okay, I could test this if I wanted to. I could take this, and if I were to distribute it back to both of the terms, when I multiply it by the 1, I will get 2y minus 1, like I have there. Okay, so nice. So at this point, I got this quadratic factored. I split the middle to factor it. Okay. Well, I substituted to start the problem, so I'm going to have to substitute back in for the y. So that gives me x squared t, and now if I use this factoring here, I'll get my first parentheses, my second one. I'll have 2, I'm going to leave some space for the y, -1, and then 8, leave some space for the y, and then +1. And now anywhere there's the y, I'm going to plug in my t cubed. So 2t cubed and then 8t cubed. Awesome. Okay. Are we done yet? It turns out no, not quite. So one of these parentheses can be factored a little bit more. So which one can be factored a little bit more? So give this thing another 1-minute pause. See if you can identify which one of these parentheses can be factored more. 4, 3, 2, 1. Pause it for about a minute and try this thing. See if you can figure out which one gets factored more. Okay, so let's bring it back. It turns out the second parentheses is, I got some perfect cubes in here. So this will be something cubed and then plus something cubed. Let's start with the 1 because that's easier. What cubed is 1? Well, that's just 1. And then what cubed is 8t to the third? Well, that's 2t. So I indeed have some perfect cubes. The first parentheses might look like perfect cubes, but the 2 is not a perfect cube like 8 is. So this actually won't be difference of cubes in that first parentheses, just the second one. Okay, so let's do our difference of cubes. Or sorry, this is the sum of cubes because I'm adding. Okay, so let's do that. So I still got x squared t out in front, and then I still got times 2t cubed minus 1 times that. And then I'm going to have my sum of cubes. So I know sum of cubes involves, two kind of parentheses. And if I think back to my formula for sum of cubes, it became like x plus y times x squared minus xy plus y squared. Okay, so if I plug in for my x and for my y in this, well, so my x is this first thing getting cubed, that's 2t. My y is the second thing getting cubed, that's the 1. Okay, so I'm going to get the x, which is 2t, plus the y, that's the 1, times x squared, that's the 2t, that quantity. So I got to put in parentheses, the whole thing is getting squared, minus x, which is 2t times y, which is 1, and then plus the y squared. So that's that 1 getting squared. Because that's what I'll get if I plug in these terms into my sum of cubes. Now I just got to simplify it a little bit. The stuff in this second parentheses can be simplified a smidge. So I got x squared t times 2t cubed minus 1 times 2t plus 1. And then times in parentheses, I'll get 4t to the 2. And then multiplying minus 2t. And then I finally get that plus 1. Cool. And remember what we said about difference of cubes and sum of cubes before? The stuff in the second parentheses pretty much never factors further. So I don't really need to try with that. And with this one, it's pretty clear that the thing in the first parentheses is simplified as far as we can take it. So this is as far as I can go. This is my answer. Okay, so one of the big things to kind of take away from this section is you might have noticed that there's been kind of a step up in difficulty in this factoring section. And that's very normal. This section is kind of the typical section where the difficulty does step up because we're really incorporating a lot of algebraic methods. It's not always as clear cut what's going to be the method. Like, am I going to need to use difference or sum of cubes or difference of squares or grouping? Sometimes I'll have to use a combination of those. So it's going to take us practice to hone these skills, but we're going to really try to get as much of that as possible.